Okay, welcome everyone. My name is Alan Joyce. I'm the Director of Content Development for Wolfram Alpha. I oversee a lot of the team that ingests socioeconomic and cultural and geographic data into the Wolfram Alpha knowledge base and makes that available through Wolfram Alpha and through the Wolfram language. So today I'm just giving a brief overview of some of the work that was done in version 12 to expose and improve and better document financial and socioeconomic entities. Um, just a few references here. There was a there was a uh, page that we put out when version 12 was released that gives a good overview of um, some of the new features, some interesting things you can do with socioeconomic data at the country level, some really detailed data within the United States, and some other improvements to financial data, stock market data, company data, currency denominations, and some other links out to other useful entity types and functions in the language. Um, some of these, looking at the cultural data page, there are obviously links out to individual entity types that we've documented for the first time um, in the Wolfram language with version 12, and also other useful functions that you can use to that will consume those entity types and do some other kinds of interesting analyses on them. Financial and economic data, anybody who's been using the Wolfram language for a while a lot of people are familiar with financial data itself, lots of data on stocks. We've also expanded, and now we have separate entities that actually represent the companies themselves with a lot of additional properties focused on company fundamentals and not just on the stocks associated with those companies. Like I mentioned, version 12 for the first time, we have had these entities exposed in the language for a few versions, but this version is the first time that we've actually got dedicated reference pages for each entity type. I just find these really helpful. If you don't really understand what the scope of a particular entity type is, what the properties are that are available, just what the things are that you can do with entities of a given type. These are a nice way to expose the syntax that you can use to interact with entities, uh, representing the entities themselves, getting property values, constructing entity classes, lists of some of the properties, and then just some more examples of things that you can do with entities of each type. So just getting into some of the examples here. For people who aren't familiar with the entity framework in the Wolfram language, just very quickly, this is a really easy way to get direct access to data in literally hundreds of different entity types within the Wolfram language. The easiest way of accessing is just through natural language, same way as Wolfram Alpha. So control equals will open up a box like this. You can type the name of an entity. Uh, that gets interpreted and turned into the canonical representation of a particular entity. And you can see the tooltip here. This is an entity object of type country, and its canonical standard name is France. You can discover and find entities a bunch of different ways. You can just get random entities of a particular type. Um, you can get a complete list of all the entities of a given type. Uh, Property access, you can just within the language get a list of all the entity properties for a given type of entity. And then just accessing the data. If you've got an entity, you can just request uh, the value of a single property. You can pull up multiple values for multiple properties. And then you can also add additional things if you want to get the property values back, but also get them returned in an association or a data set where the values are tagged with the actual property or even the entity and property pairs that are associated with the value. You can do that. Data set access can be really nice. You can, for a given entity, you can get, this is also useful, especially when there are a lot of properties. You can request just a property association, but you can also get a non-missing property association, which will just automatically remove any values that are missing for that entity. So in domains where the data might be sparse for some properties, this is a good way to get straight to the data that's actually available for a specific entity. Um, And this can be kind of overwhelming, so sometimes just the data set view is a nice way to explore data for a single entity or even for multiple entities, and just be able to kind of page through values for uh, that given entity and look through all the properties, or even a subset of properties if you want to specify them. And then, of course, one of the great things about the entity framework is that entities just work very cleanly with other functions in the language. So, for example, using a geonearest function, finding company entities, the first 50 near whatever the center point that we have for Chicago is, and generating a plot of those. And then you could also access data for each of those, plot that data however you wanted to. Financial data, like I mentioned, that's been around for a long time, will also work with entities themselves, and uh, also return values by default now. These financial data used to just return by default um, just numbers, just reals for things. And now everything comes back as appropriately, uh, with the correct currencies for the given exchange that stock is listed on. So everything is fully specified quantity objects here. Or even things like Wikipedia data. We've gone to a lot of effort to try to align entities in many domains to Wikipedia, Wikidata, and so you can actually just directly uh, access the summary plain text or the full text of a given Wikipedia article. You can extract images. This is all just leveraging the Wikipedia API and our alignment to external sources like that to get direct access to that data in the Wolfram language. So moving on to some specific examples, country data itself is one of the oldest data packlets integrated into the language. The country data function still exists, but we really are recommending that people start to shift their code over to using standard entity syntax. It's just more flexible. As we add things, new methods for applying functions, doing filtered entity classes. These are things that are just much more powerful for looking up and filtering and finding and analyzing data than the old country data type functions. So, for example, we've sourced data from a lot of different NGOs and other public sources, curate and clean, and sometimes find problems with and report problems with that data. But it makes it really easy to get a lot of useful data at the country level, for example. So this is constructing an implicit entity class, not a named entity class like NATO or Africa, but an entity class of type country. We want to look for the unemployment rate. We can wrap that in dated, so we're looking for unemployment rates in 2009, and we're going to take the 10 largest values here, and then actually retrieve that value. Um, that will come back as an entity association. So we've got the entities, we've got their values, and then those values can be fed directly into something like bar chart. We can start visualizing that data. Um, this entity association, like I said before, this is really useful. Whenever you use that here, for example, we're just getting countries in Africa unemployment rates in 2016, getting that as an entity association. So again, we've got the entities, we've got the values. Because we've got the entities associated with the values here, that can just drop straight into other geographic visualization functions. And these values will get centered at the right place on a map. Or if you wanted to do a choropleth map, a georegion value plot function, same kind of thing. You can just feed this kind of data structure into that, and the geo functions are going to place the data and scale it correctly with whatever kind of visualization you're generating. Uh, One other thing about country data has long had sort of a standard core set of properties. We've expanded them over time uh, because the regular entity interface is more directly tied into everything that's available in Wolfram Alpha. We've added a lot more properties there. There are a lot more detailed business statistics, education statistics, and other kinds of demographics and socioeconomic data we've exposed within the last couple of years. So business statistics are kind of interesting. These are things where, again, with natural language input, you can ask something like Portugal business statistics, And that's going to give you a data set of a whole bunch of related properties associated with that country. China trade facilitation, again, to a lot of people, these might be sort of somewhat obscure terms. So another thing that's really helpful about the entity framework is for a given property, it's just the property itself, not associated with a specific entity. But you can get definitions for many properties that give you, some more information about if it's a number that doesn't really have a unit. This will explain indexes and other kinds of ratings and things that need some context to understand. And these are sourced and edited somewhat, coming from whatever the direct source is that we got the data from. And again, you can do some interesting things here, like let's take countries in Asia, and we're going to get data for 4 of these business-related properties, and then we can uh, generate heat maps of each of those things and start comparing values for countries in a region for a bunch of different things related to shipping and customs and port infrastructure here. Like I mentioned, also, a lot of other expansion in areas like educational data. So there's sort of basic data on, total enrollment of students and teachers, but then you can also dig into more detailed data, like, male primary students. Uh, the thing here that I want to call out, and as we've added more and more complex socioeconomic data, the way that a lot of that data ends up getting exposed is not as increasing the length of the list of core properties that you get in a domain. It's adding more qualifiers to core properties. So, for example, this is just the core property, which is pupils, just for display purposes, the common name that shows up is students here. But you can ask for qualifier values for that property, and that'll tell you that this property can take the additional qualifiers that include date, and this can just be any date spec, but also a bunch of other categorical things, including education level, gender, whether it's a per capita value, whether it's a population fraction, and then a split between general and vocational pupils. Uh, and so, to have separate properties for every possible combination of these things would increase the list of entity properties enormously. And really, this is the kind of thing where you probably want to be able to build these up programmatically and do lots of comparisons of male versus female at all different education levels. And so that's the kind of thing you can do here. We take pupils, and then we just build up some tuples of different combinations of education level and gender. Uh, and what we can get out there is uh, something that looks like this. We've combined all these different possible combinations of education level and gender, and then we can retrieve those individual values. And you can see that at the core, these are each still just the pupils property, but with different qualifiers applied to them. And so it's a lot more data than it might even seem when looking at the already pretty long list of properties for the country domain. And then, once you've got these accessible, the entity property, uh, these identifiers are things you can pick into, and so you could generate um, a table, make a data set here that pulls those identifiers back out, and you can look at, female primary students, male primary, female secondary, and just get that into a data set form. And then again, that's the kind of thing that can just be fed directly into geo visualizations and start looking at that data. Um, in the US, especially, there's a lot of additional data that is available for many different geographic entity types within the US. So from the national level through state, county, even down to city, school district, zip code. We've sourced a lot of data from different US statistical agencies. This, for example, there's some data on crime that comes from the FBI's Uniform Crime Report each year. Um, this is kind of just showing a way to kind of dig in and look for properties that you might not know the name for. And here I'm looking for anything that's got crime rate in the canonical name. So we've got total, property, and violent crime rates. Um, Here, digging in and looking for uh, properties about specific types of crimes, pulling those out. Um, we can go to a specific state, administrative division, entity type, um, looking for each of these rates, um, looking at all available dates for those, and getting property association. So then just what you get back here will be 3 time series, and then feeding those into dateless plot. You can look at changes in total property and violent crime in Alabama, over the time period that we have data available, all the way back to the 1960 really. Here we can take a look at cities within a certain range of another location. So let's say this is looking for cities within 20 miles of Pittsburgh, and getting wherever crime data is available, getting motor vehicle theft rates, um, and then generating a heat map here. So looking for areas where those rates are significantly higher than others. And here, this is a fairly complicated function, but kind of interesting to see the kind of thing you can do with the data that's available here. Taking total crime rates for all US states over the time period from, let's see, 1990 to 2015. And this is already rendered here, but generating a heat map and then being able to just step forward through all that data. And over time, looking at how the crime rates have actually changed, just maintaining the same scale here. But you can see, uh, from a lot of Western and Southern states being maybe 8,000 per 100,000 people in the 1990s. And by now, crime rates overall have dropped dramatically. It's just an interesting way to just pull that data, have it available right in the language, and be able to generate some really powerful visualization here to tell a story. Also, there's a lot of really detailed data on demographics that we've got from the American Community Survey from the US Census Bureau. This is a replacement for what used to be the long form, the census long form. So it's a survey that's done every year. There are 1, 3, and 5-year releases. The 5-year releases are what we use because they provide estimates that go all the way down to zip code level and below, down to census tracts and block groups. So it's the most detailed data available, and it covers things like languages people speak at home, marital status, age, sex, education level, educational enrollment, all kinds of interesting data. And we've got the subset of, from working with people at the census, some of the most popular, most frequently requested pieces of data from that data set are directly available in the language. I'll point out something here that's not immediately obvious maybe, but looking at administrative division entities. And so for US states and counties, this would cover these. There are a number of different population properties. So this is a case where there's not just a core population property and then say an educational attainment qualifier or a migration qualifier. These are separate population properties because the core values are actually different. There's sort of a different base population here that applies in each case. For educational attainment, it might be only the population over or equal to age 18. For language spoken at home, it's maybe the population age 5 and up. But these are different baseline populations that then the rest of the values are measured against. And again, looking at each of these properties, you can get a definition that gives you a better idea of what that number actually represents. So, educational attainment, this is the population greater than or equal to age 25. Migration greater than or equal to 1, language greater than or equal to 5. So these are, when you're getting values for any of these things, you don't want to compare them to the total population for that area. You want to compare them to the total population that's defined by that property. A little complicated, but it's important to understand if you're working with this kind of data. And again, lots more data than is immediately obvious that's contained in property qualifiers. So for example, educational attainment. There are different categories here for different levels and ranges of educational attainment, also male, for gender. You can also directly get data about margins of error estimates for each property value. Or get percents instead of just total values. So for example, you can do something like, knowing that there's a doctorate value for educational attainment. I want to get the population number of people with a doctorate in Palo Alto, and so that's 6,571 people. Or maybe I really want to see that as a fraction of that population. And again, that's the population greater than or equal to 25. And that turns out to be about 13.8% of the population of that area. Then I could expand that. Let's say I want to find, I'm going to take an entity class that's all the US counties in California. I'm going to get the population by educational attainment, all the people with a doctorate. Again, look at the percentages and see where all the PhDs are concentrated in California. And really probably not that surprising when you look at it, but still it's an easy way to visualize that kind of data. And you can do that for any of those other properties related to educational attainment, enrollment, income, all these other things. Language, this was kind of an interesting example. This is not about the total number of language speakers, but this is a census question that asks, what language do you speak at home? So there are 40 some language categories. Some of these are, like I said, they're categories. They're all African languages, but then there are also specific languages that are tracked by the census and that you can ask about. We could do something here like, let's look for, let's see, we'll do this. We can construct a couple of properties. This is language spoken at home. Let's compare Spanish or Spanish Creole, the Spanish category that the Census Bureau defines, and Chinese. We'll take those languages. We're going to retrieve those for all the zip codes in Los Angeles. Get rid of any missing values where there's no data available for a zip code. And then we can do something interesting here and generate a smooth histogram showing the distribution of people who speak those languages at home in that area. And you can see kind of this part of Chinese speakers through this area with a neighborhood out here, Spanish speakers kind of distributed most strongly here, some more population out here, and some overlap there through the middle. But it's this kind of thing, again, that's really interesting to do with all these different kinds of really, really detailed property qualifiers. Moving on to company data, financial data. Like I mentioned before, we've had data about stocks in the language for a long time. So, picking a set of stocks, some major tech companies. These are all financial type entities, and so their standard names are generally the exchange they're listed on and the ticker symbol. And you can access these in financial data, get their closing prices. With version 12, there are also now distinct entities that are available for the companies associated with those stocks. So just to illustrate that, the entity type name, you can apply that to an entity and it tells you what canonical type that thing is. So these stocks are all, again, financial type entities. But then I can make an entity value call for each of those and get the associated company, not a lot of difference here other than uh, some name variations, but you can see, on mouse over or again, just using entity type name, these are company entities. So related and connected, but a very different set of properties that are available for them. So for example, here, this is just getting companies. Let's get total revenue, profit, income, operating income, net income for about a 5-year span. Um, and then you can start generating some plots and digging into that data, comparing companies this way. Uh, Again, I mean, there's really a lot of data here. There are more than 150 properties available for companies. Um, it goes on and on. Uh, for a given company, you can, and going back to the beginning, sometimes the easiest way to dig in here and understand what you're working with is just grab a data set of all the data available for an entity. And so again, deleting some missing values here, and out of that 150 or so, there's 124 for Apple that there's actually data available for. And these are lots of different things, some categorical things, some grades, company logos even. And again, looking at property qualifiers, this is a different kind of thing here than in some of the demographic data, but uh, for some purposes, really useful to be able to um, directly get this data um, on an annual, quarterly, or TTM, trailing 12-month basis. And you can see kind of the difference in the plots that you get from that. For different kinds of operations you're doing, you might want one of the other versions of those. And also worth noting that while for companies that are listed on North American exchanges tend to have a lot more of this data available, um, for other companies that are listed, companies outside of the US, outside of North America, data may be much more limited. There are also private companies that are available in the company entity type, but they are likewise there's much less of this data available because that's is coming from reports that we can only really get for public companies. Um, I think I mean that's most of what I wanted to cover today. Um, there are, like I said, there's a good reference page here for some of these examples I've gone through, a few other ones that you can explore at your leisure, and some other links out to other associated functions and the entity types that we're covering here. Um, okay, I think the notebook I had will be available after the talk if people want it. And thanks very much for your time.